Hello students, today we will be seeing sets theory. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the same. Please note that the part of the content may have been generated using generative AI, which is experimental. So in this, we will be covering subset definition. Not a subset. What do we mean by not subset? Equality of subsets, proper and supersets, Singleton set, subsets of set of real numbers, intervals, and we will be seeing some questions based on this theory. First of all, what do we understand by this word subset? So if you are having a set A, simply a set A is said to be a subset of another set B if every element from set A is also a member or element of set B. Simple. Meaning, any element from A set must be in the second set, which is B. Then you will call this A set as your subset of B. In other words, so simply the notation is this. So A subset B, so we read it as A subset B. Meaning every element belongs to the set A also belongs to the set B. Clear? So we often use this imply symbol. So using this symbol, we can write the definition of subset. A subset of B if for every A belongs to set A implies that element A also belongs to set B. I hope this mathematical definition is clear to you. Now, an example. So from the definition we just saw, every set A is a subset of itself. Meaning we can write A is a subset of A. Why? Because from definition, every element from this set belongs to the set A. Clear? Now, since the empty set phi has no element, we agree. So we agree to say that phi is a subset of every set. Yeah? Or in another words, we can also say that there does not any element from this set which doesn't belongs to this set. In another words. Clear? Now, not a subset. So if A is not a subset of B, A is not a subset of B, we write A not subset B. So symbol for not subset is just simply for if you cancel the subset symbol, then you will get your not subset symbol. So A not subset B. Example. Let A, this set in roster form with elements A, E, I, O, U, and set B in roster form with 4 elements A, B, C, D. Now, try to see, is A subset of B? And also check vice versa, is B a subset of A? Let's see. if in order to be A a subset of B, we require that every element from A set must be in B set. Let's verify. So A belongs to A belongs to B also, okay. E belongs to A while E doesn't belongs to B set. So not a subset. So A is not a subset of B. Now what about B to A? Let's cross check. So B belongs to B while B doesn't belongs to set A. So B also not a subset of A. So A not a subset of B, also B not a subset of A. I hope this is clear, the definition as well as this example. Now equality of subsets. Simple. If A and B are the same set, so that we have A contained in B, we also read it as A contained in B. Why? Because every element from this set belongs to the set B. So A is containing in set B and B containing in set A. If these two conditions are fulfilling, then you can directly say that your both sets are equal sets. If you recall the set equality definition, we saw both set must have exactly same elements. And these two conditions enforce that these two sets must have exactly the same element. Example. A in roster form with element 1, 3, 5. B in set builder form. A collection of X such that X is your odd natural number and that odd natural number must be less than 6. If you write B set in roster form, what you will get is simply 1, 3 and 5, these three elements. Now from set equality definition, you can directly say that as both sets containing exactly the same elements, so both are equal. But in context of subsets, you have to fulfill two conditions. First one is A subset of B and second one is B subset of A. As you can see, for this, we have to show that for any element or every element from set A belongs to set B. As you can see, yes, it is following. And for this, we have to show that every element of set B belongs to set A. This is also true. So both conditions satisfying, hence we can say that A is equals to B from the perspective of subsets. Here. Now, proper subsets and superset. Let A and B be two sets. If A contain in B and A not equal to B, then A is called a proper subset of B and B is called superset of A. Clear? It will be clear when you see an example. So example, assume we are considering set A in roster form with element 1, 2, 3 and another set B in roster form with 4 elements 1, 2, 3, 4. Now, first question is A subset of B? Let's see. 1 belongs to set B, okay. 2 also belongs to set B. 3 also belongs to set B. So every element from set A belongs to set B or contained in set B. So A is a subset of B. So far so good. Now, in order to be a proper subset, we require the condition that A not equal to B. Yes, it is already stated in the definition. Two conditions must be fulfilled in order to be a proper subset. which is one is A must be subset of B and A not equal to B. So we have seen A contain in B, meaning A is a subset of B, while A, and you can easily see that A not equals to B. So fulfilling both the condition imply that A is a proper subset of B. Whenever you have such case, when you write A contain in B or A is a subset of B, this set will be your superset of A. Superset is simply a set which contain another set. Simple. Here B is containing set A elements in itself. Clear? I hope both the terms are clear to you. Now, singleton set. As the name suggests, single. So a set having only one element. Simple. Suppose we are having a set with single element A. So such sets will be your singleton sets. Clear? Now, example. Consider the sets. So we are considering 4 sets. First one is empty set. Second is A set with 2 elements 1, 3. B set is with 3 elements in roster form 1, 5, 9. C set is in roster form with 5 elements 1, 3, 5, 7, 9. Now, we have to just insert the symbol of subset and not subset between each of the following pairs of sets. So first one is phi blank B. Second one is A blank B. Third one is A blank C. Fourth one is B blank C. Now, solution. As from the definition, if you recall, we stated there that we agree to say that phi is a subset for any set. For any set. So, whenever you see phi and any set here, you immediately put the symbol for subset. So, phi is a subset of every set. Always remember that. For second, A is not subset of B. Why? Very simple. In order to be a subset, we require that every element of set A must be in set B. Here you see 1 belongs to both sets, while 3 belongs to set A but not in set B. So 3 belongs to A but not in set B. So A not subset of B. Third, A is subset of C. Why? As condition says, every element of A must be in set C. As you can see, 1 belongs to A, 1 also belongs to C. 3 belongs to A and 3 belongs to C. So both elements from set A belongs to set C. So we say that A is a subset of C. And in here we can also say that C is your superset of A. Now for fourth, B is a subset of C. Why? Very simple. 1 belongs to B, 1 also belongs to C. 5 belongs to B, 5 also belongs to C. 9 belongs to B, 9 also belongs to C. Meaning all these 3 elements from the set B also in set C. So by definition, B is a subset of C. And here we can also say that C is your superset of B. Clear? More examples. So we are considering 2 roster form sets. First one with 5 elements A, E, I, O, U. second or B set with 4 elements A, B, C, D. So first question is A a subset of B? Second question is B a subset of A? Now, solution. Now set A is simply with 5 elements in roster form A, E, I, O, U. And B with 4 elements A, B, C, D. Now, in order to be a subset, or in order to be a subset of another set, we require the condition that, in this case, in first point, every element of set A must be in set B. As you can see, one by one, A belongs to A also belongs to B. E belongs to A, but E does not belongs to B. I belongs to A, I does not belongs to B. So, we can easily say that A is not a subset of B. So, A is not a subset of B. Now for second point, we are having these two subsets, not subsets, two sets in roster form. So, A belongs to B, A belongs to A. B belongs to B while B doesn't belongs to A. So, from this only you can say that B is not a subset of A. In order to be a subset, we require all the elements from B must belongs to set A. Clear? Implying B is not a subset of A. I hope the solution steps are clear to you. Now, subsets of set of real numbers. Simple. So, your set of natural number also a subset of real number. Your set of integers also a subset of real numbers. Set of rationals also a subset of real numbers. And some other subsets, simple. Irrational also a subset of real number. And here they also have inter subset properties like n contain in set of integer, integer set contain in set of rationals, and set of rational contain in set of reals. Simple. Clear? Now, intervals as subset of reals. So starting with open intervals. So first we pick two elements from reals A and B such that A is strictly less than B. Then collection of all real numbers, so Y, all real numbers in between A and B. So we are collecting all real numbers in between the chosen A and B. So this collection, this set will be your, in terms of intervals, this will be your open interval set, which is indeed a subset of reals and is denoted by in interval form as open brackets A comma B. These two open brackets suggest that we are using or we are collecting in between numbers not equals to A and B. Clear? We are not in this set, we are excluding the endpoints which are A and B. All the points between A and B belongs to the open interval A comma B, but A, B themselves do not belongs to this interval. So this representation on number line will be like this. This is our number line. AB interval is simply collection of all real numbers in between A and B. And these two open circle suggest that we are excluding A and B from our open interval set. And this blue line indicates that we are collecting all numbers in between A and B. Now, for closed interval which contains the endpoints, also is called closed interval. Simple. So, just we saw open interval in which we do not include the AB points or the endpoints. If you include both of them, then that interval will be your closed interval and denoted by these square brackets. These closed interval A comma B. Thus, this represent in roster form collection of all real number such that X is greater than equals to A and less than equals to B. So we are including A and B here. So representation is like this. So real number. Now here we are, as you can see, shaded this small circle representing that we included both A and B points. Now, half closed and half open intervals. So we can also have intervals closed at one end and open at other. Like this, for example, closed at left side, open at right side, and open at left side, closed at right side. This represents what? So first represents simply collection of all real numbers such that X is greater than equals to A but strictly less than B. So here we included A while excluded B. Now for second, this is your collection of all real numbers, all X, such that X is strictly greater than A but less than equals to B. Here we excluded A but included B. Clear? So whenever you see this square bracket, you immediately conclude that that endpoint is going to be included in our set. Now some related example. So if you see your interval like this, closed at 0, open at infinity, this is your set of non-negative real numbers, meaning we are starting from 0 or we are collecting all real numbers including 0 such that your real numbers are positive. Or in set builder form, you can say that collection of all real numbers X such that X must be non-negative. Open interval minus infinity to 0. So simple, this notation is for infinity, we are reaching to infinity. Minus infinity, we are reaching to minus infinity. This is simply negative real number set. Open interval minus infinity to 0. We are excluding 0. So always remember that we do not use close sign for infinity, as this is not a number. This is just a representation. that we are approaching towards infinity. Clear? Now, whenever you see, always remember that we do not use closed bracket sign for infinity as well as for minus infinity. We always use open brackets or these round brackets. Now, this set represents the complete set of real numbers. Complete set, the whole real number set. Clear? Now, length of an interval. So far you have seen 4 intervals: open interval, closed interval, and 2 half open, half closed intervals. So in all cases, the length is simply given by b minus a. So this represents your length of any interval. Clear? Of this form. Now, universal set. So usually in a particular context, we have to deal with the elements and subsets of a basic set which is relevant to that particular context. Meaning, while studying the system of numbers, we are interested in the set of natural numbers and its subsets, such that the set of all prime numbers, even numbers, odd numbers, multiples of 5, and so on. Now, this basic set is your universal set in this example. So, universal set is simply set of naturals. So, in order to describe your universal set, you must have your context in relevance. So, in what context you are talking about, it must be very important here. The universal set is simply denoted by capital U and all its subsets denoted by these capital letters A, B, C, etc. For example, for the set of all integers, the universal set can be the set of rational numbers or, for that matter, the set of real numbers. It, in generally in questions, either it is given to you, the universal set, or mainly it is given to you. Otherwise, student can take a different universal set and answer will vary. So, for another example, in human population study, if you are doing or anybody is doing human population studies, then the universal set is going to be all the people in the world. Simple. Clear? I hope the universal set, what do we mean by that? And here the context is very, very important. In which context we are talking about, then we can only describe our universal set. Now, some related questions. If a set is a subset of B and B is a subset of C, can you conclude that A is a subset of C? Solution. So, from the given condition, if X belongs to A, then X belongs to B. Why? Because A is a subset of B. And if X belongs to B, then X also going to be inside C because B is a subset of C. Therefore, we started from a member of A and concluded that that member belongs to the set C. So, we are having X belongs to C whenever X belongs to A. So, indeed, A is a subset of C. This property is called transitivity of a subset. So, final answer is simply yes. If A is a subset of B and B is a subset of C, then A is a subset of C. Next, is the empty set a subset of every set? Why or why not? Simple. So we know that a set A is a subset of B if every element of A is also in B. That is, A contained in B. The empty set has no elements. Let A, we are considering set A as empty, B any set. Since there are no elements in A, there is nothing that could possibly violate the condition. Yes? There doesn't exist any element which going to be violate the subset definition. So we agree to say that empty set is a subset of every set. Simple. Clear? Now, just provide an example of two sets where neither is a subset of other. Solution. Considering set A with element 1, 2, 3. Set B with element 3, 4, 5. Now A is not a subset of B. Why? Because 2 belongs to A but not in B. Same goes for 1. And B is not a subset of A because 4 belongs to set B but not in set A. Clear? Now this question, can a set be a proper subset of itself? Simple question. No, it cannot be. Why? If you recall the definition, it explicitly said that A two condition must be fulfilling in order to be a proper subset, that A must be a subset and A not equals to B. Here we are saying that can we have a proper subset to itself? No. Simple explanation. A set A is called a proper subset of B if A is a subset of B and A not equals to B. It explicitly mentioned that A not equals to B or itself. So if we consider A, so the condition is not going to be satisfied, A not equals to B. So we cannot have proper subset of itself. Clear? This question, is this given set a singleton set? Very simple question. Yes, this is our singleton set. Why? Because a singleton set is a set with exactly one element. Clear? This question, describe the relationship between the set of naturals and set of integer. So we are talking about in context of subsets or supersets. Easy question. Set of naturals is a subset of set of integers. So simply, if you recall the roster form of naturals, which is simply denoted by 1, 2, 3, 4, so on, and set of integers, minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3, 2, plus infinity. As you can see, every element from this set belongs to the set of integer, as you can see. So your set of natural is simply a subset of integers. In another words, in terms of superset, you can also answer the set of integers is a superset of set of natural numbers. Clear? So this is it from this session. Thank you.